Alright, good morning everybody. This is Justin here. I've been getting quite a couple of requests from people asking me how I took the MCAT and did the math section without using a calculator. So I thought I would make a quick little video, I don't know about quick, but a little video showing the tricks I used to do math, to do arithmetic, to do logs, and scientific notation without using a calculator. So if you asked, this video is for you. So I'm just going to give you a bunch of tricks, a bunch of examples, a bunch of example problems to show how I did the problems. And then what you need to do is you need to practice this. And eventually, once you practice it enough, the tricks will all just become second nature. And you'll be able to look at a problem and know exactly which trick to use in one. But you got to practice is the key takeaway. So these are the tricks that I devised to do math on the MCAT quick without having to do long division or long multiplication. So I hope this is helpful. We're going to start with arithmetic. And one of the first tricks I can show you is, just check my sheet over here. Let's say we have division, multiplication, and division. So 80 divided by 5. Normally in grade school, the way we did it was like this. We would take 5 and try to force into 80 and see how many times we could do that. But that takes a long time. So the way I did it on the MCAT is to split up the numbers in the numerator and denominator. So we see 80 is a big number. We can split 80 into 20 times 4, and we keep the 5 in the denominator. And we see that 20 divided by 5, we can simplify it, gives us 4, because 20 divided by 5 is 4, times 4 left up top, and then we can just do 4 times 4, which is 16. So we split up the numbers first, and then we simplify from there, and that just makes it so much easier. Alright? Now, let's talk about multiplying decimals. Let's say we have another problem where we have 0.2 times 0.8. The way I like to do this is to convert both to fractions. So 0.2 turns into 2 over 10, and then 0.8 turns into 8 over 10. And I multiply the fractions, so I multiply the tops and the bottoms. So 8 times 2 is 16, 10 times 10 is 100, and then 16 divided by 100. Anytime I divide by 100, I just move the decimal point twice to the left. So I get 0.16. So just plain and simple like that. Alright. Now let's say I want to go this way, 120 divided by 200. So this is going to be a messy problem to do out because the bottom is bigger than the top. But what I can do is, you see how there's a 0 up top and a 0 on the bottom? I can just cancel out the zeros. So I get 12 over 20. And then once I get to this, I'm going to keep reducing down this fraction until I can get to an easy fraction that I can work with. So let's say I divide the top by 4 and divide the bottom by 4. 12 over 4 is 3. 20 over 4 is 5. And we know that 3/5, since it's a common fraction we normally work with, is equal to 0.6. So that's how we do this problem without having to do all that long division. We just simplify the fraction down. We'll cross out the zeros first, simplify the fractions until we get to something easy that we can work with. Alright? Now, what if we have a mixed operation? Something like this, 40 times 36 times 24. So this would take a long time to do out, and we'd probably end up making some sort of mistake by the time that we did the long multiplication and the long division. So the way I like to do this one is I like to split each of the numbers into factors first. And then once we get it into factors, we can cancel and cross things out. So do you see how 40 can get split into, let's say, We can split it into 4 times 10, but we can further split it into 2 times 4 times 5. That's 40. And then 36, we can split it into 6 times 6. And then 24, we can split it into 4 times 6. So now we split all the numbers, all the big numbers, into smaller numbers, into their factors. Now we can just look at what's on the top and what's on the bottom, and if they're the same, we cancel them out. So we have a 4 up top and a 4 on the bottom, so those go away. We have a 6 up top and a 6 on the bottom, so those go away. So now all we're left with is 2 times 5 times 6. So 2 times 5 is 10, times 6 is 60. So that's how we can do that big, ugly problem very quickly. And doing it quickly saves time on the MCAT, so we don't have to waste time just doing simple arithmetic. Alright? Now what happens if we have a square root? Nobody likes square roots. Square root of 0.04. The easy way to do this, and you won't always be able to do this, but you can try it. Chances are in the MCAT they'll give you nice simple numbers like this. The way I like to do it first is I like to change it to a fraction. Alright? So 0.04, that's going to turn into 4 divided by 100. Alright? So square root of 4 divided by 100. We didn't change anything, we just changed the decimal to a fraction. And what we can end up doing is, if there's a fraction inside the square root, we can split the square root. So square root of 4 divided by square root of 100. And then we just evaluate each one separately. So square root of 4 is 2. Square root of 100 is 10. And then once we get to that, 2 divided by 10, when we divide by 10, we move the decimal 1 to the left, so we just get 0.2. Alright? So far so good. So it's a lot of converting things to fractions and reducing them down, or converting things to factors and canceling them out. And that's really the beauty of, shortcuts like this. Alright, let me show you one more problem, or a couple more problems for arithmetic. Alright. Now what happens if we have a problem like this? 10500 times 310. These are two really big numbers we have to multiply. Chances are, if you see that you have two big numbers that are being multiplied, that's a good indication that you should use scientific notation. Alright? Converting things to scientific notation will make your life so much easier. So, scientific notation, remember, you try to make the first number between 1 and 10. So, let's say we put a decimal point here. So we get 1.05. And then to get back to regional, we move it, the decimal place 4 places. So we get times 10 to the 4th. This one, 310, we're going to turn it to 3.1 times 10 to the 2, because we moved the decimal twice to get back to start. So now we're going to multiply these. Alright, so these numbers here, on the MCAT, we're just going to round them down. So we're going to round it to 1.1 times 10 to the 4th and 3 times 10 to the 2nd. Just round it and go. And then now we multiply these. So when we multiply scientific notations, we're going to multiply the first numbers. So 1 times 3 is 3. And then for the exponent, we're going to add the exponents. So 4 plus 2 is 6. So that's your answer. It's so much easier than having to do it the long way with long multiplication. Alright? I'm going to give you another trick with arithmetic here. And it's how exactly do we convert a decimal to a fraction? Because I've been saying it this whole time, but I never showed you guys how to go from decimal to fraction. So let's say we have 0.653. That's our decimal. And we want to turn it to a fraction. So some number over some number. Alright, here's the rule. So the first thing you do is you look at the number of digits after the decimal, to the right of the decimal. So here we see we have 3 digits after the decimal. And here's what you do. You take those digits, you put it on top of the fraction, put in the numerator, and then you put a 1 in the denominator. The number of digits after the decimal here matches the number of zeros that come after the 1. So here we look at the digits. We have 1, 2, 3 digits, which means that we're going to have 1, 2, 3 zeros after the 1 in the denominator. And this is how you turn a decimal into a fraction. All right? It took me a while to remember, to figure out, just because I haven't done that since elementary school. All right, so those are our tricks for... Let me just make sure. Let me see if there's another good example I can give you. Alright, so those are the basic tricks for arithmetic. Okay, so next I'm going to show you guys some tricks with scientific notation. So I know that we used a little scientific notation before, but this is going to show you a little more on how I used it. A couple more tricks that might be useful. Scientific notation. So a lot of tricks coming at you, but all you have to do, all these problems I'm doing, redo them after you finish this video and see if you can remember my tricks. And after you practice enough times, the tricks will become second nature. Alright, so when you have something in scientific notation, let's say we have to take the square root of something in scientific notation. So the tricks I showed you earlier were the basic cases with scientific notation. Now these are the ones where it gets more complicated. So square root of 3.5 times 10 to the 9th. A very common square root you'll have to do on the physics section since the numbers are so big and so small. Alright. The thing with scientific notation is here. You can actually move the decimal point here any direction you want as long as you adjust the exponent on the 10. So since we know that we want to take a square root, we want to try to make this number here, we want to turn into a number that's easy to take the square root of. So if it's 3.5, that's a hard number to take a square root of. But let's say it was 35. That's close to 36, and we can take the square root of 36. So what we want to do is we want to move the decimal point here to turn it into 36. But then since we move the decimal point, we have to adjust the exponent. So let's think. 3.5, we started with 3.5 times 10 to the 9. 10 to the 9 means we have to move this decimal 9 times. But since we changed it, since we moved the decimal to 35, since we moved it and changed the number, that means we have to move the decimal less times to reach the same point as the one up top, because we moved it over one place already. So now we have to move it 8 times. So it's times 10 to the 8th. That's the way I do it in my head. Alright, so now once we get to here, we can split up the square root again, just like before. So we get, that should be 35. Square root of 35 times square root of 10 raised to the 8th. So square root of 35, we're just going to approximate this, pretend it's 36. Square root of 36 is going to be 6. Alright? And then when you take the square root of a 10 raised to the 8th, what you do is you take the exponent, you keep the 10 the same, but you take the exponent and you cut it in half. So it's going to be 6 times 10 to the 4th. There's your answer. All right, so not too bad. What happens if we have a fraction in scientific notation? What do you do here? We could take 1 and divide it by 25, but that's going to take a lot of work. So what we are going to end up doing is we're going to use a couple of tricks to simplify it. So we want to figure out what this evaluates to, but we don't want to do long division. So what I'm going to do is I'm going to say, okay, the denominator, if the denominator was 10 or 100 or 1,000, that would make it really easy to simplify. So to do that, I'm going to make an equivalent fraction. I'm going to multiply this, the denominator, by 4. I'm going to multiply the numerator by 4. And when I do that, I end up getting 4 over 100. So the goal was to get the denominator as 100 as some multiple of 10. All right? So now this can get simplified really easy. This turns into 0.04 times 10 to the 10th. So now this, you could leave the final answer like this, because you convert the fraction to a decimal. Or if you wanted to make this number between 1 and 10, then you could move the decimal point and get 4 times 10 to the 8th. So both of these answers would work. All right, and that's scientific notation for you. I just wanted to show you one last problem, actually, with scientific notation. What happens when you divide by scientific notation? All right, so 1 divided by 5 times 10 to the negative 4th. Very messy problem to do with long division. So we're going to take advantage of fractions. And if we recall with fractions, when we multiply two fractions, we multiply the tops and we multiply them by the bottoms. So we're going to try to decompose this fraction and split it up and write it as the way it looked before we multiplied two fractions together. So we're going to split it up. Since it's multiplication, we can split anything up. So we're going to split it into 1 over 5 times 1 over 10 to the negative 4th. And we can see that if we were to multiply these two fractions together, we would end up with exactly what we started with, because 1 times 1 is just 1, and 5 times 10 to the negative 4th is our denominator. So once we get it to here, now we simplify it. This turns into 0.2, because 1 divided by 5 is 0.2. It's one of those common fractions that we can remember. This, we have 1 divided by 10 to the negative 4th. And we remember with exponents there was a rule that if we have a negative exponent, if we move it across the fraction bar, it would turn to a positive exponent. So this would turn into 10 to the 4th, because we move it upstairs and the negative is going to turn to a positive. Then we put the two parts together, multiply them, and that's your final answer. All right? Short and sweet. So next, I'm going to show you guys how to do logarithms without a calculator. This is the tricky part. Logarithms. A lot of people don't like logarithms. I don't even know how to spell logarithm. Logs, okay. Excuse my English. Alright, so logs, probably the best thing you can learn with logs is how to convert between log form and exponent form. So if we remember from Algebra 2, if we have a log base b times y with the argument of y equals x, we can rewrite it as b raised to the x is equal to y. So this is one of the most important formulas you have to memorize. And the way I memorize it is that the exponent comes after the equal sign. So you just take the little letter on the bottom, the little number on the bottom, raise it to the exponent, and you set it equal to the other variable. So b raised to x equals y. So this can help you simplify, solve problems, because let's say you have to do log, you have to evaluate log base 10 of 100 equals, what does that equal? Well then, if you can rewrite it in this form, you can logic your way through the problem. So you take 10, you raise it to something is equal to 100. And once you get to here, you ask yourself, what number do I raise 10 to get 100? And the answer is 2. All right? Because 10 raised to the second power gives you 100. So log base 10 of 100 is equal to 2. So a log is just a different form to write an exponent. I don't know why they needed 2 ways, but that's the way it works. A couple of properties with logs I'll give you, and you have to memorize these, unfortunately. If you have log of 2 things that are being multiplied inside the parentheses, that's the same as having a log of each thing separately but added. So we went from multiplied here to separating them and adding. If you have a log of something that's being divided, that's the same as taking the log of each thing by itself and then subtracting. And if you have the log of y of some number raised to some number, you can take this number and bring it outside, and you get z log by. So we just took this thing up here and we stuck it down there. That's all we did. So these are the rules of logs you're going to have to memorize. And there's also a little chart that I'm going to give you that you're going to have to memorize, because this will save your life on the MCAT. I'm going to say memorize the following. Log base 10 of 2 is equal to 0.3. Log of 3 is equal to 0.5. And log of 5 is equal to 0.7. So you're going to have to memorize this. Alright, just know it off the top of your head. Alright? And now once we know those, we can start to do problems with logs. I'll show you. Alright, let's say we have example. Let's say we have to do log of 500. And when there's no little number down here, it's assumed to be 10. So log base 10 of 500. Alright, so we just have to, when you're doing logs, you just have to play around with these rules. Move some numbers around and see it, and keep going until you get somewhere. So I look at this problem. 500 is a pretty big number. So I'm going to try to split it up. So I'm going to get log of 5 times 100. Alright, we just split up that thing, the 500. But we look up here, and we see that when we have 2 things that are being multiplied in the parentheses, we can separate the logs and just add them. So this log of 5 times 100 is going to equal log of 5 plus log of 100. Now, we just have to evaluate these two. Log of 5, if we look up at our chart, that equals 0.7. So this is 0.7. Alright? And now log of 100, well, it's not on our chart, but we can solve for it. Log base 10 of 100. Let's rewrite it in this exponential form up here and see if we can figure out what the number is. So 10 raised to some number gives us 100. So that means the number has to be 2. So this turns into 2. And now we just add these two parts together. So 2 plus 0.7 is 2.7. That's our answer. And if we check on our calculator, and we did log of 500, we get something very close to 2.7. 2.698, which is pretty much 2.7, all right? So that's how you do the log without a calculator. You use these rules and you try to fit the problem into it. All right, so it's not horrible. All right, now what happens since things always get more complicated than they have to be? What happens if we have a log of a scientific notation? Let's say we have log times log of that number. All right, so we're going to do the same thing as before. We're going to take this and we're going to try to split it up. Well, here it's already split up. So we have two things that are multiplied, so we're going to use this property up top, and we're going to write it as log of 8 plus log of 10 to the minus 6. All right, so here's what we're going to do. Now we have to evaluate these two parts. So log of 8, let's try to write it as exponential form. This form right up here. So log base 10 of 8, which means 10 raised to some number is going to give us 8. So this is tricky because there really is no whole number that we can raise 10 to get 8. But what I'm going to do is I'm going to round this number to 10. So 10 raised to what is equal to 10? If it was 10, then the number would be 1. We would get 1, right? But since 8 is a little less than 10, I'm going to round our answer down a little bit to 0.9, all right? So that's going to get us close enough. So we basically rounded to get an answer, and then we rounded again to make up for the fact that we rounded. All right, now this side. We're going to turn it to exponential form again. So we're going to have 10 raised to some number gives us 10 to the negative 6. And if we look here, we have a 10 on this side and a 10 on this side, a question mark, and a negative 6 on here. So the number, the question mark, must be negative 6. All right? So we got 0.9 on this side, negative 6 on this side. Now all we have to do is add them together. So 0.9 plus negative 6. All right. That should give us about negative 5.1. And if we put into the calculator to check, what is the log of 8 times 10 to the negative 6? We get negative 5.09, which is very close to negative 5.1. And on the MCAT, close enough is good enough. All right, so that's logs. There's a special kind of log. It's called the natural log. And by definition, that is log base e. And we just call it ln. Very important in calculus, but no calculus on the MCAT, so we don't got to worry about what it is. When it comes to doing problems with ln, you just have to remember that this formula here, ln of some number, if you want to find the ln of some number, all you have to do is find the log of that number and multiply it by 2.3. All right? That's all you have to do. Find the log of that same number and multiply by 2.3. Don't ask me why that works. It just works. So let's do an example. Let's say we have ln of 1,000. All right? So we have to find ln of 1,000. So first, let's start off by using this formula. So first, we're going to find the log of 1,000. And then we're just going to multiply it by 2.3. All right, so let's start with this part. How are we going to find that? So log base 10 of 1,000. Remember, we're going to write it again in exponential form. So we're going to get 10 raised to what number is equal to 1,000? And that number is going to be 3, right? Because 10 raised to 3 is 1,000. All right. So we got that. Log of 1,000 is 3. Now we just have to multiply this number by 2.3. And when we multiply it by 2.3, this might be a case where you do have to do it like this, but it's nice and quick. 3 times 3 is 9. 2 times 3 is 6. We get 6.9. All right, and that's the ln of 1,000. And if we check it on the calculator, 6.9. All right, so I hope I've convinced you that this shortcut works. And for the MCAT, if it's close enough, it'll be good enough. It'll get you where you're going. All right, so the last math topic I'm going to talk to you about is something that you might see more on the physics section. This is a type of multiplication called crossing or dotting. So this comes into play a lot when you're doing physics, when you're calculating something called torque. So torque is it's a force, it's a twisting force, it's a type of moment that causes rotation. So the definition of torque is R crossed F. All right, and these are all vectors. Well, you can calculate work. Work is equal to F force dot D. Work is energy. It's measured in joules or kilojoules, and it's equivalent ability to do energy. Or energy is the ability to do work, rather. And what happens is, when you see these special signs in between the variables, this is called a cross product. And a cross product and a dot product are used anytime that you're multiplying two vectors. So remember, a vector, it's a number quantity that also has a direction attached to it. So whenever you see a letter with a bar over it like this, that means you're talking about a vector. It has a quantity, but the direction also matters. So anytime you multiply two vectors together, so R is a vector and F is a vector, you have to decide which way you're going to multiply. And this X symbol, this means a cross. This means cross multiplying. This dot down here, this means you're going to dot multiply it. And you don't actually have to know what exactly it means for the MCAT. They're not going to really test you on what the definition of cross product or dot product is. But just know that when you cross two vectors, you get another vector. But when you dot two vectors, you get a scalar. And a scalar is just a number. The direction doesn't matter, all right? So when you cross two things, when you're finding torque, you can either cross both vectors, or you can do R times F and just multiply it by the angle between them, sine theta. Likewise, when you're calculating work, you can take the dot product between them, and I won't go into how exactly you do the dot product or cross product. You either do the dot between them, or you just do work is equal to F times D times the cosine of the angle between them. So notice here we took the bars off the letters because these are no longer vectors. We basically took the vectors and we only took their number value. We're ignoring their direction here. And we're adding in a cosine or a sine. So what you have to remember is that if you're working with vectors, like here, these are all vectors. This is a vector, this is a vector, this is a vector, this is a vector. If you're already working with vectors, and you know they're vectors because there's bars over the letters, you don't have to use trig. You just have to do R and cross to F, or F dot to D. However, if you choose to not work with the vectors, if you choose only to work with the numbers, R and F and D, you're just ignoring the directions, then you have to use trigonometry to compensate for the fact that you're not looking at the direction, to compensate for the fact that you're ignoring the vector directions. All right, so that's just a key distinction. I won't go into why that's the case, but for the MCAT, these are the formulas that they generally have you use. Alright, so I just want to do one last problem to tie everything together, to put together everything we learned. Let's say we have a problem like this. Really nasty problem, a lot of decimal places. There's two ways to do it. I'm going to show you each way. The first way is to use fractions. Remember, that's the very first trick that we learned. So we're going to convert both of them to fractions. So 0.15 is going to turn into 15 over 100 divided by this one turns to a fraction. So remember how we convert decimals to fractions. We write the number, divide by, we put a 1 in the denominator, and we count how many digits after the decimal point. 1, 2, 3, 4, 5 digits. And that tells us the number of zeros that come after the 1. Alright? Now we just simplify this fraction. So when we divide a fraction by a fraction, we keep the first one the same. But then we flip the second one and we multiply them. Alright, so now we're going to evaluate this. We see some zeros on the top and the bottom, so we're going to cross some of those zeros out. So now we get 15 times 1,000 divided by 75. Now let's see if we can simplify this. So 15 divided by 75. Let's picture a clock. You know how a clock is every 15 minutes? So if we have 75 minutes, that means 15 goes into 75 about 5 times, I believe, right? Because 1 hour is 60 minutes, and a little more is 75. So this turns into 1/5 times 1,000. 1/5 we can turn to 0.2 times 1,000, and when we multiply by 1,000, we just have to move the decimal place 3 times. So we get 200. That's the first way with fractions. That was a long way. The second way is to use scientific notation. Alright, convert both to scientific notation. So 0.15 to convert to scientific notation is going to be 15 times 10 to the negative 2. 0.00075 is going to be 75 times 10 to the negative 5. Alright? And once again, we just simplify. 15 divided by 75 is 1/5. Right? Because, like I said before, you have a clock. Just picture a clock. 15 minutes, 15 minutes, 15 minutes. If you go all the way around the clock, you get 60 minutes. Plus another 15 minutes is 75. So there's 5 pieces. Times 10 to... Alright, so now we have to simplify the tens. And when you simplify scientific notation, you're going to subtract the exponents. So negative 2 minus negative 5. It's going to turn to negative 2 plus 5. It's going to give us 3. So we get this, and this we can simplify to 0.2 times 10 to the third. And we see that if we expand this out, we're also going to get 200, just like before. So that's 2 ways to do the same ugly problem, but either way, it was still faster than if we did the long division, the way we learned in elementary school. So those are my math tricks for the MCAT. I'm sorry this video took so long, but I hope this helps, and good luck. Best of luck with studying for the MCAT. Let me know how it goes, and take care.